and welcome to adding fractions. So please title your paper and don't forget to write the date. And we're going to start by a quick review of 4th grade standards. So, a little misconception alert is that when you add fractions, you should just add your top number and your bottom number. This is something I frequently hear students have been taught, but we need to understand why we're doing that. So, if I look at the top number, its vocabulary word is numerator, and the numerator tells one how many pieces we have. Pieces you have. And it's separated from the bottom number, what I've heard a lot of students say, which the vocabulary word you should be using is your denominator. And the denominator and the numerator are separated because the top numerator tells us how many pieces we have, and the denominator tells us how many pieces make up the whole. How many pieces make up the whole. So we're separating those two by a line in the middle because a fraction is a division problem. So I have 3 out of 4, or 1 out of 4. So you can write it and model it several different ways. So if I look at, I like to think of food. If I look at a circle, I can pretend it's a pizza that's cut into 4 slices. That would be 4 makes up the whole pizza. 4 slices make up the whole pizza. But I have 1 slice out of the 4. So that would be 1 area shaded in. Then if I look at my second, I could pretend, well, let's say I have a pan of brownies, delicious gooey brownies. And I have 4 pieces make up the whole. I can draw my lines vertically, or that is not to scale. So my fourths are not equal, and they should be, but there it is. I'll extend it a little bit. And out of those 4 pieces, I have, here's running out, I have 1, 2, 3 shaded in for 3/4. So when I add those in in 4th grade, they typically say add your numerators and forget about your denominators. Well, that's fine if your denominators are the same, if you have like denominators. So you would say 4 still makes up the whole, and 1 plus 3 gives me 4 pieces. 4 pieces out of 4 equals 1 whole. So when your numerator is the exact same or equivalent to your denominator, that always equals 1 because it's saying you have that many pieces out of however many make up the whole. So even if I have a number like 792 as a numerator, as long as my denominator is the same, 792, then I have 1 whole. Any number, as long as the numerator and denominator are the same, make up your 1 whole. So now that we have that, we're going to look at adding fractions with unlike denominators. So there are a few ways to do this. The first way I'm going to teach you is a fraction strip, which if we had fraction strips at home that we could use, we would bring those out, but we can also just use them as drawing a model. So I like to start with a base of 1, just so I have something to compare the size of my fraction to. So that's a 1. The 1 is just the base. It's not in a part of my problem. The problem that I'm going to solve is going to be, let's do a 3rd plus 2/6. So here, I can't do what my 4th grade teacher told me to do and just add the top numbers because my denominators are different. So, when I'm using fraction strips, I will just draw out under my base and put the fraction strips together. So I start, and I'm going to try to do it to scale as best I can. Obviously, I'm a really good artist, but not so good that I can do everything to scale. So this would be about a third, and notice I did this in blue, and that's my first addend. My second addend is 2/6. So if I did 2/6, that would be 1/6, 2/6. And so then I would have to see, well, what fits here? That'd be the difference. But what do I have all together? Well, if I look, I need to find a common denominator. And my common denominator between 3 and 6, I can use multiples for. So if I do multiples of 3, 6, 9, 12, and then I do multiples of 6, because that's my denominator, 6, 12, 18. Whenever I see one that repeats first, so here I have 3, well 3 is not over here. Here I have 6, but 6 is over here. So 6 would be my lowest or least common denominator. And I could keep going with just plain common denominators. I could say, well, 9 doesn't repeat, but 12 repeats. So 12 is a common denominator, but not my least or my lowest, which would be 6. The least or lowest common denominator just means whichever one you would hit first when you make multiples of your denominator. So multiples of 3 are 3, 6, 9, 12. Multiples of 6 would be 6, 12, 18. So whichever one I hit first, that's the same. That would be my least common denominator. And all the others that come thereafter, those are just common denominators that you can use. So going back to how we add them together, here I have a third plus 1/6 plus 1/6. Well, if I find common denominators, I can do what my 4th grade teacher told me and just add my numerators. So I know that identity property, anything times 1 equals itself. Well, if I look here and I want to have common denominators, I know that 6 is a common denominator. So this I won't have to do anything to because it's already a 6. But the 3 is not a 6 yet. So in order to find an equivalent fraction of 1/3, I need to make those in 6 so that I can add them together. So 1/3, I can multiply that by a common denominator of how many times do I need to multiply 3 to get 6? Well, I have 1, 2. It's my second multiple, so I can multiply it by 2 halves because 2 halves equal 1. So I'm finding equivalent fractions when I multiply by 2 halves because really I'm using the identity property. So I simply multiply my numerators 2 times 1, and that's going to give me 2. And then I multiply my denominators 2 times 3, that gives me 6. So now I have 6 in both addends, which means I can go ahead and add those together. So if I add 2, 6, and 2, 6, I get 4, 6. Remember, you add your numerators, not your denominators, because my numerators say how many pieces I have. My denominator tells me how many make up the whole. So now, I know that I should be able to get 4 6 out of this. Because that 1 6 and 1 6 equals the 2 6 equals 1/3. So I could say 1/3 plus 2 6 equals 4 6 because I know that 1/3 equals 2 6. These equations are equivalent. They are equal to one another. So that's the fraction strip way. It's just simply you draw it out in fraction strips. That's it. That's all you have to do. So now, if I wanted to do an estimate, which would be what I'm doing next, if I estimate, I'm going to estimate to the nearest benchmark. So when I look at a number line, I think about, money we do in quarters. So I would have 0, and then I would have 1 over here at the end of my number line. And in the middle, because I'm working with numbers that are less than 1, I know half is in the middle, and here I have a 1/4, here I have 3/4. So when I'm looking at estimating, I'm rounding to the nearest benchmark. So I know my benchmarks are a half, a whole, and 0 right now. So benchmarks are going to be broken up to the number that comes before, which this time happens to be 0 because I have 1/3 plus 2/6. So since I have numbers less than 1, I'm either going to go up to 1, down to 1/2, or down to 0. So if I think about 1/3, where would that fall on my number line? Well, 1/3's a bit bigger than 1/4, so I know that 1/3's about here. So I can round up to 1/2 or down to 0. Well, it's closer to 1/2, so I would round 1/3 to 1/2. And then the 2/6, well, that I have to think to myself, where would that be on a number line? Well, it would be bigger than 1/4, less than 1/2, so it would round to about 1/2 as well, because it's near 1/2, so we round it there. So here I just say 1/2 plus 1/2, that equals 1/2. And if I think about my estimate, I know that when I solved before, I got 4/6, which is near 1/2, closer than it might be to 1/2. So these are rough estimates because 4/6 would technically be closer here. So remember, whenever you estimate it, just to get a nearby number. It's not necessarily to get the exact number or super close, because they're just supposed to be really quick facts that you can do to see where you should end up. Make sure you're not in the hundreds place when you should be in the tenths place. Okay, now that we have estimating, rounding to the nearest benchmark, if I did a number like, let's say 2.5 plus 1 1/3, when I thought about my benchmarks for 2.5, I know my maximum would be 3 and my smallest amount would be 2, because I'm either going to round 2.5 up to 3 or down. But remember, I also have 2.5 here. So if I have 2.5, my benchmark is my actual add-in. And then if I thought about 1 1/3, I would either round up to 2 because it's the next whole number after 1, or round down, or I would stay in the middle at 1.5. So I'm rounding to whichever number comes before, whichever number comes after, or whichever number is in the middle. So I have 1 1/3, that's about around, maybe around here. So I would probably round 1 1/3 to 1/2, 1 1/2. It just gives you a really fast way to look at it. Okay, so now that we have our estimates down, we're going to look at adding with common denominators, which we kind of already did. So this is just the algorithm. And with the algorithm, I can do a couple of different ways. I can do problem like, let's say I have 1/4 plus 3/12. I can look at this and I would say, okay, if I'm doing algorithm, do I have common denominators? No, I do not. So I'm going to make a quick list of multiples. Multiples of 4 would start at 4, then 8, then 12, then 16. Multiples of 12 would be 12, and then 24, and then 36. So if I'm spotting which my lowest common multiple is, I would use 12 because I see 12 here first and 12 here first. Well, 3/12 is already in 12, so I'm just going to leave that the same. And then to make 1/4 an equivalent fraction in 12ths, I need to multiply by 1/2. So I have to think, what 1/2 could I use? Well, I know that 1, 2, 3. 3 times 4 equals 12. So if I do 1/2 of 3/3, then I should be able to find an equivalent fraction in 12ths. 3 times 1 is 3. 3 times 4 is 12. So now my denominator is the same. I can go ahead and just add up my numerators. So 3 plus 3 is 6. I do not add my denominators, that's 12. So that's how you do standard algorithm. And then I know that I may have numbers that look something like this. 3.5 plus 1 1/3. And if I have, these are called mixed numbers because they're mixed with wholes and fractions less than 1. So when I do this, there are two options. I can do a little trick to find an equivalent fraction greater than 1, which would be denominator times whole plus numerator. Denominator times whole of 3 would be 6, plus 1 would be 7. So 7, and then I just bring down my denominator. 7 halves equals 3 1/2. And then I can do the same thing with this mixed number. 3 denominator times my whole of 1 equals 3, plus my numerator of 1 equals 4. And then I bring down my denominator because 3 times 1 is 3 plus 1 is 4. So you multiply denominator by whole and then add numerator. That's your new whole, or that's your new numerator. Your denominator stays the same. Denominator stays the same. So that's an option of doing it. So now I still look and say, do I have common denominators? No, I do not. So I have 2, I can do multiples 2, 4, 6, 8, 10. Multiples of 3 would be 3, 6, 9, 12. Well, which one do I hit first? Because that's going to give me a fraction that I probably won't have to simplify. I see that I hit 6 here and I hit 6 here. So, since I hit 6 for halves, I know that 1, 2, 3, 3/3, which is 1 whole, will give me an equivalent fraction in 6 because 3 times 7 is 21. 3 times 2 is 6. Then I have 3 times 2 because it's a second multiple. So that's 2 halves as a whole number. 1. 4 times 2 is 8. 3 times 2 is 6. So now my denominators are the same and I can go ahead and add my numerators. 21 plus 8 is 29. And I do not add my numerators. That's 6. So this is called, where the numerator is larger than the denominator, this is a fraction greater than 1. So since this is a fraction greater than 1, I can write it this way. Or I can know a fraction is a division problem. Fraction is a division problem. So 29 is divided by 6 because that'll tell me how many sets I have. 29 divided by 6. I do not start in my tens, I start in my ones. And 6 times what, I have to say, would give me close to 29. 6 and 6 is 12, 12 and 12 is 24, but 6 times 5 would be 30, so that's too big. So I have to say 6 goes into 29 4 times, which is 24. I subtract and I get 5. Well, now in 5th grade, we don't write 5, remainder of 5, R5. We put our remainder as a numerator, and we put our divisor, as our denominator, just like it was before. So 4 and 5, 6 is the same as 29, 6. They're the same exact value. So I know that was a lot, but we will definitely review it. And as long as you have those notes down, you'll be ready to go.